Let's talk about factorials. N exclamation point. If I say 5 factorial, according to this definition, we take n times n minus 1, which would be 4, times n minus 2, which is 3, and all the way down until we hit 1. So this is 5 factorial. It's a way of writing out a long product that we're going to use in these permutations. 11 times 10 times 9 times 8. We can write that using factorials because this is really times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you better be saying, wait a minute, you can't just multiply by all these numbers. You're changing the value. And yeah, you're right, I am. But if I divide by the same number, now all I've done is I'm changing the form, not the value, because these two parts would cancel out. So on the top, on the numerator, I have 11 factorial. On the denominator, I have 7 factorial. Amazing. Look at how we can modify that. And we can evaluate something like this simply by working in reverse. Now, there's a couple definitions here. N factorial, we can say that that's really the same thing as n times n minus 1 factorial. Or we could extend that to this idea up here. We could say this is n times n minus 1 times n minus 2, or n minus however many factorial. And by this reasoning, 0 factorial equals 1. And wait a minute. 0 factorial, 0 times everything less than it down to 1. How does that work? You can't get to 1 from 0 by getting smaller. But if we talk about 1 factorial, that would be 1 times 1 minus 1 factorial. According to this definition, that's equal to 1 times 0 factorial. Well, what would 1 times anything be? Well, it's 0 factorial. And 1 factorial is just 1. So 0 factorial does equal 1. It's kind of weird. There's no real physical meaning for it, but it's an idea. 0 factorial is 1. So let's simplify this. 6 factorial minus 5 factorial divided by 5. All right. Well, I see a bunch of 5s, so maybe I can do something with this 6 factorial. That's 6 times 5 factorial, isn't it? And it's saying I want to factor, which means I need something in common to both of these terms, and I've now gotten that. I'm going to factor that out as the greatest common factor. 5 factorial over 6 minus 1 divided by 5. Well, look at this. What's 6 minus 1? It's 5. Those cancel, leaving us with simply 5 factorial. Who would have thought that this funny looking thing ends up being 5 factorial? I want to back up here. I'm going to go back to this problem. There is a notation that we can use called permutations. You'll see it like this, or P, NR, or N, PR. I think I got the order there right with the letters. Or NPR. We can use this permutation thing to solve this problem. And it goes back to changing this into factorial form. This is the same thing as 10 factorial divided by 10 minus 4 factorial. Because isn't this really times 6 factorial over 6 factorial? And those would cancel. So 10 minus 4 is 6 factorial. So N stands for how many things total there are. And R stands for how many things I want to put into order. So this problem I could have solved using this permutations calculation. Permutation of 10 things total put into orders of 4. That's going to equal 10 factorial over 10 minus 4 factorial. which is what we end up with up here in green. The calculator can do this too. If we go under our menu down to probability, there's some calculations. You'll see this permutations and another thing called combinations, and that's also where you find the factorial key.